Mhm. Hey guys, good morning and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So people, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Quickly let me know in the chats with some fire emojis. Everyone in the chats, if all of you can hear me perfectly. Everyone in the chats, people. Everyone, yes, this is going to be one of the finest, one of the amazing sessions, my dear students. And you guys are definitely going to love it for sure, right? I know all of you were desperately waiting for this particular session, which is the NEET 2024 Chemistry Paper Predictor. So in this particular session, I will be solving 35 questions with you. And right after me, HSP sir will be solving 15 questions with you. So in total, we are solving 50 questions with all of you, right? And all the questions which we have come up with in the today's session, my dear students, all the questions we have designed. Me and HSP sir, we have designed all these questions based on our experience, right? So that you get to know the real feel of the NEET 2024 examination. So that you get to know exactly what is going to be the level of the chemistry paper when it comes to the NEET 2024. And trust me, directly, indirectly, you'll be getting the similar type of questions which we are going to discuss in this particular session. So this particular session, let me tell you again, this is super important for all the NEET 2024 aspirants, right? So are you all ready for it? Are you all ready for it? Are you all ready for it, people? The session duration is not going to be more than 2 hours. Maximum for 2 hours, you'll be staying with us. That's all. Right? Are you all ready? I would want some fire in the chats. I would want some fire in the chats. And. Tomorrow at 4 p.m., we are going to have a marathon in which we shall be discussing 1,000 top-notch questions of your physics, chemistry, biology. That's a combined session, right? It's going to be a combined session, people. Perfect. That session, which is going to be on tomorrow, right? Which is going to be happening on tomorrow at 4 p.m. That will contain some 1,000 questions, right? Of PCB, right? So you would need to attend that particular session as well. Perfect. Perfect. So from this particular session, let me tell you again all the questions which I'm going to discuss with you, which HSP sir is going to discuss with you. Let me tell you all the questions we have designed based on our experience, right? Keeping into consideration the level of NEET 2024 examination. Perfect, people. And let me tell you again, the duration of the session is going to be not more than 2 hours. Just for 2 hours, you need to be with us. Perfect. So should we start? All ready? I can see not everyone has liked the session yet. Why is that? I can see not everyone has liked the session yet. I would want every one of you smash the like, mark your attendance right now. I would want every one of you to smash that like and mark your attendance right now. Right now. Yeah? Perfect, guys. Perfect, perfect. Perfect. Exactly. I'll be explaining all the questions in detail, right? And my dear students, I would want you guys to be active for these coming 7 days for this particular channel, right? Because we are coming up with some amazing sessions which are definitely going to help you out when it comes to your NEET 2024 examination. Okay? Perfect. All right then, let's get going. Let's get started with the session. And the first question, my dear students, that is on your screen. The first question which is on your screen. This question is from the chapter Thermodynamics. My dear students, in this year NEET 2024 examination, you can expect 3 to 4 questions from the chapter Thermodynamics. Let's have a look on the question, what the question exactly says. As per the question, we have got 1 mole of ideal gas, which is allowed to expand irreversibly and adiabatically from the temperature of 27 degrees centigrade. Work done is 3 kilojoules. the final temperature of the gas is? Have a look on this particular question. As per the question, my dear students, we have got 1 mole of ideal gas. We have got 1 mole of ideal gas, right? And this 1 mole of ideal gas, it is undergoing expansion. It is undergoing expansion. And the expansion, as per the question, is irreversible and adiabatic. It is irreversible and adiabatic. As per the question, the initial temperature of the gas is 27 degrees centigrade. That means 300 Kelvin. What are we supposed to calculate? We are supposed to calculate the final temperature of the gas, which I'm representing with T2, right? So have a look exactly how this sort of a question I will be solving. My dear students, since the process is adiabatic, if the process is adiabatic, you must know Q value has to be 0. Q value has to be 0. As per the question, how much is the work done? How much is the work done? It is given to us as per the question. During the expansion, work done is 3 kilojoules per mole, right? Since it is the case of expansion, during expansion, work is done by the system. And whenever work is done by the system, W value is taken to be negative. So W is basically equal to minus 3000 joules. W is equal to minus 3000 joules. Now, people, if you use the first law of thermodynamics, you know your delta U is nothing but Q plus W. Now, the process adiabatic, so Q value has to be 0. What is delta U? Delta U is nothing, it is NCV delta T, which is T2 minus T1. And W, as per the question, is given to me as minus 3000 joules. I believe the question is clear till here. Now, if you look at the question carefully, N value is given to me as 1. N value is given to me as 1. CV value, as per the question, is given to me as 20. Perfect. T2 I need to calculate, which is the final temperature of the gas. T1 is given to me as 300 Kelvin. It is equal to minus 3000, right? So my dear students, if you look at this particular equation, you got one equation which just contains one unknown, that is T2. Perfect. So from here, I believe you can easily calculate the value of T2. Can you let me know in the chats what is the value of T2 coming out to be after solving this particular equation? Quickly. So it is going to be T2 minus 300 is equal to minus 3000 divided by 20. Minus 3000 divided by 20. Perfect. Which comes out to be minus 150. So people, your T2 from here comes out to be equal to minus 150 plus 300. The value comes out to be exactly 150 Kelvin. This is the final temperature of the gas when the gas is undergoing irreversible adiabatic expansion. So this is something I was supposed to calculate in this particular question. I believe it's clear to everyone, right? So expect this type of the question directly or indirectly in your NEET 2024 examination for sure. Number one. Let's have a look on the second question. Look at the second question, guys. The question is from the chapter solution. The question is from the chapter solution. As per the question, you have got an aqueous solution, right? And that aqueous solution freezes at this particular temperature. Perfect. So as per the question, freezing point of the solution is minus 0.186 degrees centigrade. Perfect. Since you are using the aqueous solution means you are using the solvent as water. What is the freezing point of water? What is the freezing point of water? Freezing point of solvent that you already know, that is 0 degrees centigrade. Perfect. If I use the depression in freezing point, you know, your delta TF, depression in freezing point, that will be equal to freezing point of solvent minus the freezing point of solution. Freezing point of solvent minus freezing point of solution. Now, freezing point of solvent as per the question is 0 minus. What is the freezing point of solution? That is minus 0.186 degrees centigrade. So it comes out to be plus 0.186 degrees centigrade. This is the depression in freezing point. This is the depression in freezing point delta TF. Now, my dear students, you already know your delta TF. Your delta TF is equal to Kf multiplied by molality. And delta TF value you got to know already as 0.186. Perfect. Now, from this particular equation, can't we calculate molality? Molality will be 0.86 divided by Kf. Now, as per the question, is the value of Kf given to us? Is the value of Kf given to us? Yes, it is 1.86. The value comes out to be 0.1. So first thing which I calculated here, I calculated the molality of the solution. Now, as per the question, what am I supposed to calculate? I'm supposed to calculate elevation in boiling point, that is delta TB. You must be knowing delta TB is nothing but KB multiplied by M, and KB value as per the question is given to me as 0.512 multiplied by, what is M? What is M over here? M is 0.1. M is 0.1. Am I clear to everyone? Am I clear to everyone, people? Am I clear to everyone? Perfect. So it is just the matter of calculation here. This multiplied by this, that gives me the elevation in boiling point. So the final answer of the question is just going to be option number 4. I believe this is clear to everyone. Let me tell you again, expect this sort of a question directly or indirectly in the upcoming NEET examination. Perfect. Right, people? Moving on to one more question. Look at this particular question, guys. From the chapter Equilibrium, you can expect again 3 questions this year in the NEET 2024 examination. Okay? Have a look, people. Have a look on this particular question. As per the question, we are given with the reaction. The reaction is H2 gas plus I2 gas. It's in equilibrium with 2 times HI gas. This is the reaction that's given to us. Now, as per the question, 4.5 moles each of hydrogen and iodine. So initially, as per the question, we are starting with 4.5 moles each of hydrogen and iodine, right? They are heated in a sealed 10-liter vessel. Volume of the container in which the reaction takes place, that's 10 liter. Now, as per the question, it is observed that when equilibrium is established, 3 moles of HI were found. So number of moles of HI, which were observed at equilibrium, that came out to be equal to how much? That came out to be equal to 3. What are we supposed to calculate? We are supposed to calculate the value of Kc. This is the question. Now, people, let me assume that at equilibrium, out of 4.5 moles of H2, let's say X moles are reacted. So I'll be left with 4.5 minus X. Perfect. Similarly, this is going to be 4.5 minus X, right? Since 1 mole gives 2 moles, so from X, you get 2X. So what did I calculate over here? I calculated the moles of all the reactants and products present in the container at equilibrium, right? I got the moles of all the reactants products in the container at equilibrium. Now, as per the questions, moles of HI at equilibrium. Moles of HI at equilibrium is nothing but 2x. So 2x is equal to 3. So x value is equal to 1.5. X value is equal to 1.5. Now put the value of x here. So 4.5 minus x, 4.5 minus 1.5, that will be 3. 4.5 minus 1.5, that will be 3. 2 multiplied by x, that is also 3. So these are the moles. These are the actual moles of reactants products in the container at equilibrium. Now, if I divide with them the total volume of the container, if I divide them with the total volume of the reaction vessel, I got the concentration of each reactant product in the container at equilibrium. Since I got the concentration of each reactant product in the container at equilibrium, I can easily write the expression for Kc. Kc expression is going to be concentration of HI at equilibrium raised by stoichiometric coefficient, that is 2, divided by concentration of H2 at equilibrium raised by stoichiometric coefficient 1, concentration of I2 at equilibrium raised by stoichiometric coefficient 1. Now, if I ask you people, what is the concentration of HI? Concentration of HI at equilibrium, that is 3 by 10 ka square. So this is 3 by 10 ka square divided by, what is the concentration of H2? This, concentration of I2, this. So it is again 3 divided by 10. This is going to be square again. So when you solve this, the value exactly comes out to be what? The value exactly comes out to be 1. So the equilibrium constant value here is coming out to be exactly as 1. So it's going to be option 2, which is going to be the correct answer of this particular question. Again, I'm repeating the same thing. Expect this sort of a question directly or indirectly in the upcoming NEET 2024 examination. Right, people? I'm moving on to the next question. Try to understand. One simple question from the mole concept. And I believe all of you can easily solve this particular question. The volume of hydrogen liberated at STP by treating 2.4 grams of magnesium with the excess of HCl. So you are making magnesium to react with HCl. And you must be knowing when magnesium reacts with HCl, it leads to the formation of MgCl2. And with this, you get hydrogen gas as well. Now, if I ask you, is this reaction balanced? It is not balanced yet. So if I make it 2 times, now the reaction is balanced. Correct? Now, my dear students, look carefully. As per the question, we have got 2.4 grams of magnesium. So if I ask you how many moles of magnesium do we have, you will say given mass of magnesium divided by molar mass of magnesium. So we are starting with these many moles of magnesium, correct? Now use the stoichiometry and you're done. You're done. Stoichiometric coefficient of magnesium here is 1. Stoichiometric coefficient of hydrogen here is 1. So can I say from the stoichiometry 1 mole of magnesium when reacts with HCl, it leads to the formation of 1 mole of H2. So 1 mole H2 gets liberated. Therefore, as per the question, when 0.1 moles of magnesium reacts with HCl, it leads to the formation of what? 0.1 moles of H2. So I got to know from the question, I got to know that number of moles of H2 liberated is nothing but 0.1, correct? But do I have to calculate moles or volume? I need to calculate volume. So I'll say volume of H2 gas liberated at STP will be equal moles multiplied by 22.4 liters. The answer will be 2.24 liters. So I would say 2.24 liters of H2 gas will be liberated at the end of the reaction. Is that clear to everyone? So expect again this sort of a question in your upcoming NEET examination. And I believe you all can do this sort of equation easily. I'm moving on to one more question. Okay, this is something which you should answer. This is something which you should answer on your own. In chromyl chloride, the oxidation state of chromium is. In chromyl chloride, the oxidation state of chromium is. In chromyl chloride, the oxidation state of chromium is. My dear students, the answer is going to be +6. You should know, first of all, chromyl chloride is basically CrO2Cl2. Remember this particular structure. CrO2Cl2. Now, if you look at all the things, this is a single bond between chromium and chlorine. Chlorine is more electronegative, so it will carry -1. This carries +1. Due to this single bond, it carries -1. Chromium carries +1. Due to this double bond, oxygen carries -2, chromium carries +2. Due to this double bond, oxygen carries -2 and chromium carries +2. Now check the total charge present at chromium. It's +2, +4, +5, +6. So I would say +6 is basically the oxidation state of chromium in case of what? In case of your chromyl chloride. It is just, I want you guys to remember this particular structure. That's all. That's all, right? So expect a question from the oxidation state as well, from the structure basically. From the structure basically. I'm moving on to one more question. My dear students, look at this particular question. Again, one simple and basic one. Try to understand. A first order reaction has the specific reaction rate as 10 raised power -2 second inverse. So basically, as per the question, we are given the first order reaction. Let that first order reaction be A gives B, right? Its rate constant is given to me as 10 raised power -2 second inverse, right? How much time will it take for 20 grams of reactant to reduce to 5 grams? See guys, as per the question, what is the initial amount of reactant? The initial amount of reactant is given to me as 20 grams, right? So let's say at time t, the amount of reactant left, which I'm representing with 80, that is equal to how much? That's equal to 5 grams. We have to calculate the time taken for the reactant to reduce its amount from 20 grams to 5 grams, right? It is a first order reaction. So I'll be definitely using the integrated rate equation. I can say T is nothing. It is 2.303 divided by K. It is going to be log of A naught divided by AT. This is one of the forms of the integrated rate equation for the first order kinetics. Now, my dear students, T is equal to 2.303 divided by K. K is nothing but 10 raised power -2. This is log of A naught by AT. 20 divided by 5. 20 divided by 5 comes out be 4. And log of 4 is 0.6. So it is 2.303 multiplied by 0.6 divided by 10 raised power -2. Just a matter of calculation and get the answer exactly in seconds. I believe this is also clear to everyone. Expect again this type of the question directly, indirectly. I'm telling you only numbers might be changed. The pattern of the questions, you'll get the similar. Okay? Perfect. Right, people? I believe I'm clear with this particular question, and when you solve this, you get the final answer as 138.6 seconds. Absolutely. I'm moving on to one more question. Look at this particular question from the chapter redox. Look at this particular question from the chapter redox, or you can call this question from the mole concept as well. The volume of 0.02 molar aqueous HBr required to neutralize 10 ml of 0.01 molar BaOH whole twice. So as per the question, your HBr is being neutralized by what? Your acid is being neutralized by the base. Your acid is being neutralized by the base. If I ask you, what am I supposed to calculate? I'm supposed to calculate the volume of HBr. Let the volume of HBr be V1, right? Molarity of HBr solution is given to me as 0.02. Similarly, volume of BaOH whole twice, that's given to me as 10 ml. And in the similar way, molarity of this barium hydroxide is given to me as 0.01 molar. Correct? This is something which is given to me. Now, my dear students, HBr, what will be its N factor? Its N factor is going to be 1. If I ask you what will be the N factor of this particular base, N factor of this particular base is going to be 2. Now, if I ask you what is the normality of the first one, normality is equal to, you know, normality is molarity multiplied by N factor. So it has to be 0.02. What is the normality of the second one? Molarity multiplied by N factor. It has to be this multiplied by this. The value will be 0.02. Now, since this is the case of neutralization, if it is the case of neutralization, I can just use the equivalent concept. I can say milli-equivalence of HBr reacted has to be equal to the milli-equivalence of barium hydroxide reacted. Right? Now, milli-equivalence of HBr will be normality of HBr multiplied by volume of HBr in ml. This has to be equaled. Milli-equivalence of this will be normality of barium hydroxide multiplied by volume of barium hydroxide in milliliters. Now, my dear students, what is N1? N1 is 0.02. V1 I need to calculate. What is N2? N2 is 0.02 and V2 value is given to me as per the question, that is 10. So first of all, this term got cancelled. So V1 value came out to be exactly how much? 10 ml. So I must say 10 ml of 0.02 molar aqueous HBr is required to neutralize 10 ml of 0.01 molar aqueous barium hydroxide. I believe I'm clear to everyone, right? I believe I'm clear to everyone. Yes, there are questions from inorganic chemistry as well. Just wait. Let me finish one by one. All right. If you look at this particular question, guys, this is the question from the chapter electrochemistry, right? This is the question from the chapter electrochemistry. So as per the question, the standard reduction potential of the half cells is given. So I'm given with the SRP values. These are SRP values, right? These are SRP values. This is the SRP of NO3 negative. This is the SRP of V di positive. This is the SRP of Fe tri positive. This is the SRP of Ag positive. This is the SRP of Au tri positive. These are SRP values which are given to me, right? Now, the question says the number of metals which will be oxidized by NO3 negative. So first of all, if you see NO3 negative, its SRP is 0.97. So its SRP is 0.97. Perfect. Now this particular SRP, it is less than the first value. This is also less than the first value. This is also less than the first value. This is not less than this, right? So I'm telling you, just compare these SRP values. 0.97 is greater than this, greater than this, greater than this. I have to say this NO3 negative, the number of metals which will be oxidized by NO3 negative. Can you let me know? Can you let me know in the chats? Can you give it a thought? 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 My dear students, if you look at all these values, perfect. If you look at all these values, I would say NO3 negative, its SRP is more than this, right? So your NO3 negative, it is going to oxidize this one, and this one. It is not going to oxidize this one. Perfect. So tell me the answer directly, right? Tell me the answer directly. I'll say there'll be 3 substances which will be getting oxidized by what? NO3 negative. Correct? Simple and basic question again this is. And I believe you can solve this sort of a question. Now, when it comes to chemical kinetics, expect a question like this as well, like this format from your chapter chemical kinetics. If you look at this particular question, we are given with the reaction A plus B gives products, right? The order is 1 with respect to A and B. So the reaction that's given to us, that is A plus B, it gives products. as per the question, order with respect to A as well as order with respect to B. That's one. So if I write the rate law, R is equal to K, it is going to be concentration of A raised power 1, concentration of B raised power 1. This is how I'm going to write the rate law. Simple. Now, since I wrote the rate law, if I put this particular detail, this particular experiment detail in this particular expression, it is going to be, as per the first experiment, rate is how much? 0.1 is equal to K. Concentration of A is how much? It is 20 raised power 1. Concentration of B is how much? It is 0.5. Let's call this as first equation. Now, experiment number 2 says rate is how much? 0.4 is equal to K. Concentration of A is how much? Concentration of A is X. Concentration of B is how much? Concentration of B is 0.5, right? Call this as equation number 2. Similarly, experiment number 3 says rate is 0.8 is equal to K. What is the concentration of A? That is 0. What is the concentration of A? That is concentration of A in the third experiment, that is 40 raised power 1. Concentration of B in the third experiment, that is Y raised power 1. I'm calling this as equation 3. So how many equations I got till now? I got 3 equations. I first of all wrote the rate law. Then in the rate law, I have introduced these 3 experiment values. So I got 3 equations. Now just I have to manipulate these 3 equations. That's all. I'll be getting the answer. Now my dear students, if I divide equation 2 with equation 1, if I divide equation 2 with equation 1, it's 0.4 by 0.1, that comes out to be 4, right? 0.5 cancel, k gets cancelled. It is going to be x divided by 20. So your x from here comes out to be 40. So x came out to be 40. So one thing is done, x is 40, right? X is 40. X is 40 people, right? So I believe it's done. We were supposed to get the value of x and y. X is 40, right? X is 40. There is only one option which says x is 40. That's option B. So should I go with option B? Should I go with option B, people? Should I go with option B? Quickly in the chats. Yes, right? And if you want to get the value of y also, you can divide further other 2 equations and you can exactly get the value of y, right? Oh, have I done some mistake here? Sorry, this 40 to 80. Just a second, sorry. This 40 to 80, my bad. This is 80. X is 80 here. Yeah, correct. You all are right. X is 80 here. So X is 80 in this case as well as this case. Perfect. So it's option A or option 4. Since I divided 2 with 1, you can take other 2 equations and get the value of y. And I believe you can do that. And when you solve this, my dear students, right, X value is coming out to be 80, right? And Y value, after solving the other 2 equations, after dividing the other 2 equations, you get the value of Y here as 2. Perfect. So this is one more type of the question which can be asked. Okay. Now, look at one more question. Look at one more question, people. The question says the molar solubility of CaF2 is 0.1 molar solution of NaF will be. This sort of a question has been frequently asked in the NEET examination, and expect the same question again this year as well. So as per the question, you have got CaF2. First of all, tell me how this CaF2 will undergo dissociation. It will undergo dissociation as Ca di positive plus 2 times F negative, right? Ca di positive plus 2 times F negative. Let its solubility be S. This will be S. This is going to be 2 times S, right? Now, you are introducing the CaF2 in NaF. NaF being the strong electrolyte here, it will get dissociated as Na positive plus F negative. Now, as per the question, what is the concentration of NaF which I'm using over here? That is 0.1 molar. So initially this will be 0, this will be 0. Now, this will be finally 0, this will be 0.1, this will be 0.1. My dear students, in the same container, you have got a weak electrolyte and a strong electrolyte which have got one ion in common. What is that common ion? That is F negative. So what is the total common ion concentration? 2s plus 0.1. So 2s plus 0.1, as per common ion effect, it will get exactly equal to 0.1. Approximately it will be 0.1 only because of the common ion effect. Now people, what I need to do exactly? Just try to understand what I need to do exactly. I need to write the Ksp expression for CaF2. How do you write the Ksp expression? It is concentration of calcium di positive raised power stoichiometric coefficient, concentration of F negative raised power stoichiometric coefficient, that's 2. So Ksp value as per the question is given to me as 5.3 into 10 raised power minus 11 is equal. Ca di positive concentration is S, F negative concentration is 0.1, which means 10 raised power minus 1 whole raised power 2, right? So S value will come out to be 5.3 into 10 raised power minus 11 divided by 10 raised power minus 2. The final value will be 5.3 into 10 raised power minus 9 molar. So this is the solubility of CaF2, which I was supposed to calculate. Is there any option like that? 5.3 into 10 raised power minus 9? Yes, it's option 4, which is going to be the correct answer of this particular question. So I hope you got to know how do I approach to this sort of a question, people, right? I hope you got to know how do we approach to this particular type of the question. Okay, this sort of a question I have given you many a times in my normal sessions, right? Can you solve this? Can you solve this on your own? As per the question, your BaCl2, you are making this BaCl2 react with Na3PO4. And when BaCl2 reacts with Na3PO4, what do we get? Ba3PO4 whole twice. And with this, you'll be getting NaCl as well. Perfect. This question has been asked in JEE mains examination many a times as well, right? So people, first of all, it's time to balance the reaction. This is 3, this is 2, this is 6, and this is 1. Is that? Sorry. This is 1 and this is 6, right? So the reaction is balanced. Since the reaction is balanced, as per the question, we are starting with 5 moles of BaCl2, 5 moles of BaCl2 and 2 moles of Na3PO4. So initially this is 0, this is 0. Now if I ask you which concept you are going to use here, you will be using the concept of limiting reagent. You will be using the concept of limiting reagent. My dear students, how do you identify which one is the limiting reagent? How do you do that? Given moles divided by respect to stoichiometric coefficient. 5 divided by 3 will be 1.66. 2 divided by 2 will be 1. So this value is coming out to be lesser. So it has to be my limiting reagent. So if Na3PO4 is my limiting reagent, it is going to decide the entire product formation. Now people, have a look. This is 2 here. This is 1. So 2 mole is giving me 1 mole. Right? As per stoichiometry, 2 moles of limiting reagent should give me 1 mole of barium phosphate. Right? So 2 moles of limiting reagent should give me what? 1 mole of barium phosphate. That's something I was supposed to calculate. The maximum moles of barium phosphate that can be formed. So the maximum moles of barium phosphate that can be formed is nothing but 1. Right? Am I clear? Am I clear? I hope you can solve this sort of a question. I hope you can solve this sort of a question. Again, this is one more type of the question which has been repeatedly asked in JEE mains in the last years. So expect this question from atomic structure as well. Expect one question like this and expect one question from nodes, right? Expect one question from nodes. So we will look at this particular question. We are given with certain metals and their work functions are given. The number of metals which show photoelectric effect when light of wavelength 400 nanometer falls on it. So if I ask you what is the incident energy? Incident energy is nothing but Hc divided by lambda. Hc I'll be taking as 1240 electron volt nanometer divided by lambda is nothing but 400 nanometers. So nanometer cancelled. So this will be 3.1 electron volts. This is the incident energy. Now what is the criteria for photoelectric effect to happen? Right? What is the criteria? I would say energy of incident light should be greater or equal to what? It should be greater or equal to work function. This is the criteria for photoelectric effect to happen. Right. Look at the first metal. Its work function is 2.4, right? Its work function is 2.4. Incident energy is greater than this value. So photoelectric effect will happen. Incident energy is greater than this value. So photoelectric effect will happen. Incident energy is greater than this value. So photoelectric effect will happen. It won't happen here. It won't happen here. It won't happen here. Because over here, work function is more than incident energy. Here also, here also. So how many metals will show photoelectric effect here? Absolutely 3 metals, right? So 3 metals are going to show the photoelectric effect here. Expect, I'm telling you again, expect this question directly, indirectly in the upcoming NEET 2024 examination for sure. Moving on to one more. For the decolorization of 1 mole of KMnO4, moles of H2O2 required is. I hope you know, my dear students, H2O2, whether it behaves like the oxidizing agent or reducing agent. Its N factor, how much we take? Its N factor we take as 2, right? No matter if it behaves like the oxidizing agent or it behaves like the reducing agent. Its N factor will be 2, right? We have discussed it in detail. Perfect. We have discussed it in detail. So first of all, this reaction is taking place in the acidic medium. So N factor of KMnO4 in the acidic medium is 5. You should know it now. You should know it. We have discussed this again in detail. Now, as per the question, your KMnO4 is reacting with what? Your KMnO4 is reacting with H2O2. Perfect. KMnO4 is the strong oxidizing agent. Therefore, this will be behaving as a reducing agent, right? And when H2O2 behaves as the reducing agent, its N factor is 2. So what do I do? How many moles of KMnO4 are we given with? We are given with 1 mole of KMnO4. What is the N factor of KMnO4 here? It is 5. Of moles of H2O2 I'm supposed to calculate. N factor of H2O2 I know exactly as 2, right? Perfect. I'll just use the equivalent concept. I'll say gram equivalence of KMnO4. Gram equivalence of KMnO4 reacting should be equal to what? It should be equal to gram equivalence of H2O2. Now the point is, how do we calculate gram equivalence? Moles multiplied by N factor. How do we calculate gram equivalence? Moles multiplied by N factor. How many moles of KMnO4 do we have? 1. Its N factor is 5. Moles of H2O2. We need to calculate N factor 2. So N2 value here comes out to be 5 divided by 2. N2 value comes here as 5 divided by 2. It means that 5 divided by 2 moles. It means that for the decolorization of 1 mole of KMnO4, how many moles of H2O2 are required? I would say 2.5 moles of H2O2 are required. I just used the concept of what? Equivalence. I just equated their gram equivalence and solved the question. And I expect this sort of equation, people, again. Expect this sort of equation again, right? Okay. One more question. One more question, people. One more question. The total number of intensive properties from the following. Intensive properties. First of all, volume is extensive, right? Molar heat capacity will be intensive. Perfect. Heat capacity is extensive. Molar heat capacity is intensive. Molarity, I mean concentration, that is intensive. Your E0 cell, that is intensive. Gibbs free energy, that is extensive, right? That's extensive. So what is the answer? What is the answer, people? Quickly. I mean, this sort of a question you can easily solve on your own, because I have discussed extensive intensive properties, my dear students, in detail. I have discussed. So these are all your intensive properties over here, right? Your moles, volume, Gibbs free energy, they are extensive. Okay, and I hope you know what are extensive intensive properties. Those properties of the system whose value changes on changing the size of the system, those are called as extensive. And those properties of the system whose value does not change on changing the size of the system, you call them as the intensive properties, right? So remember these terminologies over here. Moving on, people. If you look at this particular question, can you solve this? You should be in a position to solve this. A first order reaction. Let's say we have got a first order reaction. A first order reaction is 30% completed in 30 minutes, right? So initially, let's assume its amount is A0. Initially, the concentration of reactant is A0. This is 0. Now, as per the question is concerned, in 30 minutes, 30% reaction is getting completed. 30% reaction getting completed means 30% of reactant gets converted into product. So I'll be left with 70% of the reactant. So this is the concentration of reactant left. So I would say AT is nothing but 0.7 A0. AT is nothing but 0.7 A0. So at T is equal to 30 minutes, AT is this. At T is equal to 30 minutes, A is equal to this. Perfect. Right, guys? Or if you do not want to solve it like this, you have one expression. I hope you remember. Time taken to complete X% of the first order reaction is equal to 2.303 divided by K. It is log of 100 divided by 100 minus X. I hope you know this expression as well. I have given you this expression in detail. So time taken to complete 30%. This is given to me. Time taken to complete 30%, that is 30 minutes, is equal to 2.303 divided by K. This will be log of 100 divided by 100 minus X. X is 30, so 100 minus 30 is 70, right? So it is 10 by 7. So this is the equation which I got, from which I'll be calculating rate constant. Once I calculate rate constant, you know, half-life in case of the first order reaction is nothing but 0.693 divided by K. Once you get K here, put it here and get the half-life. This is the way by means of which you can solve this question. Again, one simple and basic question. Correct? It is just you have to remember this expression. As per the question, it was given that 30% of the reaction is getting completed and we are done. And when you solve this exactly, the answer comes out to be 58.2 minutes. Correct? The answer comes out to be 58.2 minutes. Now we will look at this particular question. The question is from the chapter Ionic Equilibrium. The question is when 50 ml of 0.1 molar NH3. So you have got NH3 and you are making it to react with HCl, and you know it leads to the formation of what? Your salt NH4Cl. Perfect. It leads to the formation of salt NH4Cl. Now, my dear students, if I ask you initially, how many millimoles of NH3 do we have? Molarity multiplied by volume in ml. This multiplied by this. It gives me the millimoles of NH3 initially. Millimoles of HCl. Molarity multiplied by volume in ml. That is 10. So we have got 10 millimoles of HCl in the beginning. This is 0, right? Now, my dear students, use the concept of limiting reagent first of all. Identify the limiting reagent. This NH3 is the limiting reagent here. 5 by 1 is 5. 10 by 1 is 10. So NH3 is limiting. If NH3 is limiting, I'll be left with nothing. So there'll be 0 millimoles of NH3 left at the end of the reaction. How many millimoles of HCl will be left? 1 mole reacts with 1 mole. 5 millimoles would have reacted with 5 millimoles. I had taken 10. Out of 10, 5 are reacting. So 5 will be left, right? Similarly, 1 gives 1. So 5 millimoles will give 5 millimoles, right? Perfect. Is it? Is it, people? Is it, people? Is this how you are going to do this question? Is this how you are going to do this question? Yeah? I think one thing is people are saying, sir, this is not 10, this is 1. Yes, you are right, this is 1. This is 1. So this is molarity multiplied by volume in ml, 10 multiplied by 0.1, this is 1. So the question will be changed. So which one is the limiting reagent now? Which one is the limiting reagent now? 5 by 1 is 5, 1 by 1 is 1. So this is the limiting reagent. I'll be left with nothing. So 0, right? Now, 1 mole reacts with 1 mole. 1 millimole will react with 1 millimole. I had taken 5 out of 5. 1 is reacting, so I'll be left with 4 millimoles. Correct? Now, 1 gives 1. So I'll be getting 1 millimole of this particular salt as well. So this is something which is left in the container at the end of the reaction. This is something which is left in the container at the end of the reaction. Now, my dear students, if you look carefully, what are we left with? We are left with a base. We are left with a weak base. And this is over. And we are left with the salt of same weak base which it has formed with a strong acid. It has formed with a strong acid. So finally in the container, we are left with weak base and the salt of same weak base with a strong acid. So basically we are left with a buffer. Which buffer? Basic buffer. Which buffer? It is basic buffer. How do you calculate pOH of the basic buffer? I hope you know. How do you calculate pOH of the basic buffer? It is pKb plus log of concentration of salt divided by concentration of base, right? Or you can say log of concentration of conjugate acid divided by concentration of base. Now, my dear students, what is pKb value? pKb is given to me as 4.75 plus log of. What is the concentration of salt? Concentration of salt means millimoles of salt divided by total volume. Total volume is 10 plus 50, that comes out to be 60. Whole divided by. What is the concentration of base? Concentration of base means millimoles of base divided by total volume. So 60, 60 cancel. It comes out to be log of 1 by 4. It comes out to be log of what? Log of 1 divided by 4. So it is going to be 4.75 plus 4.75 plus. It is going to be log of m by n, which is the log of m minus log of n, right? So I'll just write minus log 4 here. Log of 1 is 0 minus log of 4. Log 4 is how much? 0.6. The final answer will be 4.15. 4.15 is pOH. But what am I supposed to calculate? I'm supposed to calculate pH. You should be knowing pH plus pOH at 25 degrees centigrade is 14. So from here you can calculate pH, which is 14 minus 4.15. The answer will be 9.85. So 9.85 is basically going to be the pH of the final solution which I was supposed to calculate. Did you get it? So first of all, I exactly saw how this reaction is taking place. Then I got to know what is left finally in the container. We were left with a weak base and the salt of same weak base with a strong acid. So we were left with a basic buffer. And I already know how do we calculate pOH of the basic buffer. Once we are done with the calculation of pOH of the basic buffer, then you can use this particular result and get the pH of the buffer. That's all. Correct? This is one more type of the question which can be asked directly. Look at this question, guys. Look at this question quickly. The question is, we are given with a cyclic process. We are given the cyclic process. As per the question, we have got 1 mole of the ideal monoatomic gas. If it is monoatomic, its Cv is 3 by 2r. Its Cp has to be 5 by 2r because the gas is monoatomic. Like, what do we have to calculate? We have to calculate QAB as well as QCA. We have to calculate QAB as well as QCA. What is QAB? First of all, if you look at the process AB process isochoric, volume is constant. And I have to calculate heat absorbed or released during the process AB. Heat absorbed or released during the process AB. Since AB is isochoric, so basically in short, I have to calculate heat absorbed or released at constant volume. And heat absorbed or released at constant volume for an ideal gas has to be N Cv delta T, which is T2 minus T1, right? So I'll be writing N. N value is 1. Cv is 3 divided by 2R. T2 minus T1. You started from here. This is initial, this is final. So final temperature minus initial temperature. 600 minus 300. It has to be 300, right? So it will be 450 R. So basically, I got the QAB value. I got the QAB value 450 R. Now, what about QCA? What about QCA? If you look at this particular process CA process isobaric, pressure is constant. So we have to calculate heat absorbed or released during constant pressure, which has to be equal to what? Which has to be equal to NCP delta T. NCP T2 minus T1. Now, N value is 1. Cp is 5 divided by 2R. Now, C to A. C is initial, A is final. So final temperature minus initial temperature. 300 minus 450. That comes out to be minus 150. Correct? So it comes out to be how much? This will be how much? This will be minus 375 R. This will be minus 375 R. Now you just need to select the options. That's it. You just need to select the options. That's it. So QAB is 450 R. Your QCA is nothing but minus 375 R. Right? So it's basically going to be option C, which is going to be the correct answer of this particular question. Okay. Now people, question from chemical bonding. From chemical bonding, expect questions from bond order, expect questions from your hybridization, shape, geometry, etc. Right? Tell me the answer of this particular question. I believe you would have solved this sort of a question many a times. Right? The question is the number of anti-bonding electrons present in O2. O2 is a 16 electron species. You know it. It is a 16 electron species. Perfect. What do we have to calculate? The number of anti-bonding electrons. So first of all, I need to write the molecular orbital configuration. I need to write the molecular orbital configuration of what? Of O2. Once I write the molecular orbital configuration of O2, then only I can decide how many anti-bonding electrons are there in O2. My dear students, if you write the molecular orbital configuration of O2, this is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px1, pi star 2py1. Calculate the anti-bonding electrons. These two are anti-bonding, sigma star. This also star, so consider these two, right? And this one and this one. So 2, 4, 5 and 6. So there are 6 total anti-bonding electrons in case of O2. Now it's not necessary they'll ask you the anti-bonding only. They can ask you the bonding electrons also. They can ask you about the bond order also. Bond order can be half of number of electrons in bonding minus number of electrons in anti-bonding, right? Yes? Perfect. Now, I'm moving on to one more question. Look at this particular question, guys. H2E. H2E. E is your group 16. E is your group 16. So basically, you are given with H2O. You are given with H2O. You are given with H2S. You are given with H2SE. You are given with H2TE. You are given with H2PO. We have to arrange them on the basis of thermal stability. You have to arrange them on the basis of thermal stability. And you know, your thermal stability is directly proportional to bond dissociation energy. Your thermal stability is directly proportional to bond dissociation energy. So tell me the answer of this question. So if I talk about H2O, if I talk about H2S, if I talk about H2SE, if I talk about H2TE, if I talk about H2PO. On moving down the group, what is happening to the size of this atom? Size of this atom is increasing. If size is increasing, bond dissociation energy is decreasing. If bond dissociation energy is decreasing, thermal stability is decreasing. So which one is maximum thermal stable? It is H2O, which is maximum thermal stable. So it has to be option C, which is the correct answer of this question. So expect this sort of a question as well. Expect this sort of a question as well, people. I'm moving on to one more question. Look at this one. Look at this one. You solve it. Till then, I'll call HSP sir, because right after me, HSP sir is going to join the stream. Okay? Just give me a second. I'm calling HSP sir because I don't want any delay in between. Yeah? सर मैं 5 मिनट में खत्म कर रहा हूँ. ठीक है, आप स्क्रीन पे रहो. पाँच मिनट में I'll be done. I just have to solve like 3 to 4 questions more. Huh? Okay. All right. The question is the number of species from the following which have square planar structure. Square planar. My dear students, if you talk about PF5, if I talk about PF5, right? How many valence electrons phosphorus has? 5. How many sigma bonds it's forming? 5. How many lone pair phosphorus has? 0. What is the steric number? 5 plus 0 is 5. What is the hybridization? sp3d. What is the type of the molecule? Type of the molecule is AB5L0. And you know AB5L0 is trigonal bipyramidal. AB5L0 is trigonal bipyramidal. Similarly, you have got BrF4 negative. If you talk about Br, how many valence electrons? 7. There's a negative charge, so 7 plus 1 makes it 8. Right? How many sigma bonds? It's forming 4 sigma bonds. Out of 8 valence electrons, it is utilizing 4 valence electrons to form 4 sigma bonds. So there'll be 4 electrons left as such on bromine in the form of 2 lone pairs. So the type of the molecule directly will be AB4L2. AB4L2 means square planar. AB4L2 is square planar. IF5 directly, the type of the molecule is AB5L1. AB5L1 is square pyramidal. It is square pyramidal, right? BrF5, it's again of the type AB5L1. So again it's square pyramidal. Again it's square pyramidal, right? You have got XeOF4. XeOF4. It is going to be AB5L1. So again it's square pyramidal. Again it's square pyramidal. ICl4 4 minus. Can you check it out? ICl4 4 minus. ICl4 4 minus. Quickly. Quickly, guys. In the chats, everyone. Someone is saying, what is L1? I think you have not watched bonding, right? Quickly, guys, in the chats. Quickly, in the chats. Quickly. This one is again sp3d2 and this one is again square planar. You can check it out. Perfect. Now what I was supposed to calculate? I was supposed to check the number of species from the following which have square pyramidal structure. Square pyramidal is 1, square pyramidal. Okay, 1, 2 and 3. So there are only 3 species basically. There are only 3 species which are square pyramidal. Okay. So the correct answer of this question is option 2. I hope this is clear to everyone. Right? Okay. One more question, people, on your screen. One more question on your screen. Quickly. You have got elements boron, carbon, nitrogen, lithium, beryllium, oxygen, fluorine. So basically, if I write them in order, lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. These are the elements that are given to us. We have to arrange them on the basis of their ionization energy. Now, my dear students, you should know, on moving left to right, what happens to ionization energy? Generally, ionization energy increases on moving from left to right. So this is the expected order. This is the expected order. But is this the actual order? This is not the actual order. Why is that? My dear students, if you look at the outermost configuration of beryllium, it is 2s2. If you look at the outermost configuration of boron, it is 2p1. So over here, this is 2s2 configuration and this is 2p1 configuration. This is 2p1 configuration. Now you tell me whether to take electron out from this configuration is easy or to take the electron out from this configuration is easy. I would say to take electron out from this configuration is difficult. So I would say beryllium will have more. Beryllium will have more ionization energy than that of what? Than that of boron. Now carbon as such, compare nitrogen and oxygen. Nitrogen is 2p3 configuration. This is 2p4 configuration. This is half-filled configuration. And to take electron out from the half-filled configuration, you have to supply more energy. That's why nitrogen has got more first ionization energy than that of oxygen. Rest, everything is same. Is there any option like this? Check it out. This was the expected order, but this one is the actual order. This one is the actual order, right? So you can check it out and the answer of this particular question will come out to be option 4. Okay. Now people, understand. Simple question. For a metal ion, the calculated magnetic moment is 4.90. The number of unpaired electrons. How do you calculate magnetic moment? You know it, under root of n into n plus 2, right? This value is equal to 4.9. Now tell me when this value will be 4.9. I'll say this value will be 4.9 when? When you tell me? When n is equal to, what has to be the value of n? Quickly. What has to be the value of n? What has to be the value of n? The value of n has to be 4, right? This will be 4 plus 2, 6, 6 4 are 24, root of 24 will be 4.9. So it's a very simple question and expect this sort of equation again. Expect this sort of equation again, right? Expect this sort of equation again. If you look at this particular complex, which is K4 FeCN6, K4 FeCN6. If I ask you the oxidation state of iron over here, it is Fe di positive. Fe di positive. What is the outermost configuration of iron? Outermost configuration of iron is 3d6 4s2. But this iron di positive. So take 2 electrons out. So take 2 electrons out. It is 3d6 4s0. It is 3d6 4s0. Perfect. It is 3d6 4s0. Correct, people? Right? It is 3d6 4s0. This is 1, 2, 3, 4, 5, and 6. Perfect. Now, in presence of the strong field ligand, it is a strong field ligand. In presence of strong field ligand, what is going to happen? What is going to happen in presence of strong field ligand? This is your T2G set and this is your EG set. Perfect. We have got 6 electrons in total here. Perfect. In strong field ligand, it causes what? It causes the pairing of electrons. It causes the pairing of electrons. So 1, 2, 3, pairing here only 4, 5, 6. So it is T2G6 and EG0. Is that? T2G6, EG0 is the configuration. T2G6, EG0 because it is your strong field ligand here. It is your strong field ligand here. Someone is asking about class 12th organic chemistry lecture. Class 12th organic chemistry marathon was taken by HSP, sir. Consult that, right? Consult that. Watch that session. That's amazing. Yeah? I believe this is also clear to everyone. I believe this is also clear to everyone. Now, my dear students, if you look at this particular question, what do you think about this one? What do you think about this one? The magnetic moment is measured in Bohr magnetrons. Spin-only magnetic moment of iron in this complex and this complex are respectively. First of all, if you look at these two complexes, over here, if you see, my dear students, iron here is in tri-positive state. Here also, iron is present in its tri-positive state. And you know, when iron is present in tri-positive state, its configuration becomes 3d5. So it is 3d5, 4 is 0. This is the configuration of iron tri-positive. This is the configuration of iron tri-positive. Perfect. Now, two cases arise here. Two cases arise here. One in presence of strong field ligand, one in presence of weak field ligand. First of all, let me make this 3d5 configuration here, how it looks like. 3d5. 1, 2, 3, 4, 5. Perfect. Now, in case of your strong field ligand, what is going to happen? Pairing is going to happen, right? And in case of weak field, pairing won't happen at all. So, in case of strong field, how it looks like? Let me make it very simple for you. In case of strong field, I'll say this electron will go here, this electron will go here, and there'll be only one unpaired electron. There'll be only one unpaired electron. 1, 2, 3, 4, and 5. So there will be one unpaired electron in case of strong field ligand. In case of weak field ligand, how many unpaired electrons will be there? All will be unpaired only. There'll be no pairing, right? There'll be 5 unpaired electrons. Perfect. There'll be 5 unpaired electrons. Now, if you calculate the magnetic moment here, it's going to be under root of n into n plus 2. If you calculate the magnetic moment here, it's going to be under root of n into n plus 2. Calculate, just get these values. So 2 plus 1, 3. Root of 3 is 1.7 Bohr magnetrons. So this 5 plus 2, 7. 7 5s are 35, right? So this is going to be 5 point something. Is there any option as 5 point something? Yes, 5.9 Bohr magnetrons. Perfect. Now you select the options. Select the option, people. Select the option quickly. Select the option quickly. This was your weak field ligand here. And this was your strong field ligand. So in presence of weak field ligand, your magnetic moment is 5.9. In presence of strong field ligand, magnetic moment is 1.7 Bohr magnetrons. I hope this also clear. So option 4 is the one which has to be the correct answer of this question. Okay. Tell me the answer of this particular question quickly. The question is, what is the correct order regarding the thermal stability of hydrides? On moving from top to bottom in case of hydrides, bond dissociation energy decreases, so thermal stability also decreases. You should know it, right? You should know it. Thermal stability also decreases. So the correct answer of this particular question will be, I would say NH3 will be having maximum. NH3 will be having maximum thermal stability, right? Now, if you look at this particular question, the bond dissociation energy in case of, you have got F2, You have got Cl2, you have got Br2, you have got I2. Generally, what happens? From top to bottom, generally, bond dissociation energy that decreases. That decreases, right? So, expected order is F2 should have maximum bond dissociation energy, followed by what? Followed by Cl2, followed by Br2, followed by I2. This is the expected order. But is this the actual order? This is not the actual order. Actual order is something like this. F2, because fluorine, because of its small size, its bond dissociation energy decreases and it comes after Br2. It comes after Br2. This is the actual order. This is the actual order. This is the actual order. Look at the options. It's going to be Cl2, Br2, F2, then I2. Right? It's going to be Cl2, Br2, F2, then I2. Expected order, you know. But what happens actually? Because of the small size of fluorine, the bond dissociation energy of F2 decreases. Right? And it comes after your Br2. So you need to remember that as well. Okay? I think I've got one more question here. Or maybe two more questions. Total number of Cl double bond O bonds in hypochlorous acid, chlorous acid, and chloric acid and perchloric acid, right? You have to talk about the Cl double bond O's, right? How many such kind of bonds are there in hypochlorous, chlorous, chloric, and perchloric acid? First of all, you should know their structures, right? This is your hypochlorous acid. This is directly given in NCERT. This is chlorous acid, chloric acid, perchloric acid. Now calculate. There is no Cl double bond over here. There is one Cl double bond over here. There are two here, three here. 3 to 5, 1, 6. In total, there are 6. In total, there are 6 Cl double bond O's. In case of what? In case of all these. Right, people? Again, one simple and basic question this was. Again, one simple and basic question this was. Well, if you look at this particular question, you have got assertion reason. The spin only magnetic moment of FeCN6 tri-negative is this, whereas FeH2O6 tri-positive is this. Few minutes back only, we discussed about this spin magnetic moment, and this is correct. This is correct. And why there is a difference of the spin? Because of the presence of the strong field ligands and weak field ligands, due to which in one case pairing happens, in another case pairing does not happen. That's the reason why there is a difference in the magnetic moment. In both the complexes, iron is in tri-positive oxidation state. Absolutely, iron in both the complexes is in tri-positive state. But is the reason correct explanation? Reason is not the correct explanation of the assertion. Right? Reason over here is not the correct explanation of the assertion. Perfect. No doubt, both the statements are correct. But reason is not the correct explanation of the assertion. Okay? What do you think about this one? In which of the following octahedral complexes the magnitude of delta naught is maximum? So where do you find delta naught maximum? Where do you find splitting maximum? See, central metal ion is same everywhere. It is just your ligands are different. Now you know strong field ligands, they cause more splitting. Now which one is the maximum strong field ligand over here? It is Cn negative, which is the maximum strong field ligand. So it will cause more splitting. So maximum splitting would have happened in case of this, in case of second one, wherein I would say delta naught value would be maximum. Simple. Strong field ligands, they cause more splitting, right? So more the splitting, more the value of delta naught. You can solve the question like this. Okay, if I ask you, what is the IUPAC name of this particular species over here? What is the IUPAC? So first of all, you'll write potassium, then it's going to be trioxylato, then it's going to be cobaltate with the oxidation state of +3 over here. So it is potassium, trioxylato, cobaltate 3. Which of the options says that? Right? Which of the options says that? Quick. Which of the options says that? So it is basically your option 4, which is going to be the correct answer of this question. Again, simple and basic. And I'm pretty much sure you could have easily solved this question on your own. Yeah, on your own. Perfect. One last question, which is again the memory-based one, because you can only solve this question if you know the structure of this particular species over here. Right? This is the last question which we have. And after this, HSP sir is going to come with the organic questions. So till now, I've solved 35 questions. Now, HSP sir is just going to take some half an hour. He'll be solving 15 questions of your organic chemistry. So you have to be here as well. So people, you should know its structure. And when you remember its structure, right? So you can easily solve this question. How many P double bond O's? 1, 2, 3. So 3 is going to be the correct answer. 3 is going to be the correct answer. So people, one thing I'm telling you over here, please and please remember, all the questions which I showed in this session, let me tell you, you can expect questions directly, indirectly from this particular session for sure. 100%. I'm giving this in writing, right? Because all the questions which I have solved and now the questions which HSP sir is going to solve, we have personally designed these questions. These are not copy pasted or from some book. It is just on the basis of our experience, right? Perfect. So do watch the session again and trust me, similar type of questions, directly, indirectly, or maybe values might get changed, will be asked in the upcoming NEET 2024 examination. Just a second, let me call HSP sir and he'll be joining in. सर आप स्टार्ट कीजिए, मैं यहाँ से एंड कर रहा हूँ. ओके